Encoding categorical variables. Encoding categorical variables in machine learning. AI intermediate level. Introduction. In machine learning, models work with numerical data. However, many real-world datasets contain categorical variables, which represent categories instead of numbers. Examples of categorical data include feature example values, city Toronto, Ottawa, Montreal, payment method credit card, debit card, PayPal, product category electronics, clothing, furniture. Machine learning algorithms cannot directly process these text categories. Therefore, we convert them into numeric form using a technique called encoding categorical variables. Encoding categorical variables is an important step in data preprocessing and feature engineering. It is widely used in applications such as customer analytics, recommendation systems, fraud detection, marketing prediction models, e-commerce analytics. Understanding categorical encoding helps learners build machine learning models that can process real-world datasets effectively. What are categorical variables? Categorical variables represent data that belongs to a specific category or group. In simple words, categorical variables equals data that represents categories rather than numbers. Example dataset, color, red, blue, green. Example concept, categorical values means encoding means numeric representation. To use these features in machine learning, they must be converted into numeric values. Why encoding is important? Machine learning algorithms perform mathematical calculations using numbers. If categorical values remain as text, the model cannot process them. Example concept, text categories means cannot process means convert to numbers. Encoding helps convert text data into numeric format, allow machine learning algorithms to process categorical features, improve model training efficiency. Without encoding, categorical features cannot be used by most machine learning models. Types of categorical variables. Categorical variables are usually divided into two main types. Nominal variables. Nominal variables represent categories with no natural order. Example, color, red, blue, green. Example concept, categories with no order means nominal variables. Ordinal variables. Ordinal variables represent categories with a meaningful order. Example, education level, high school, bachelor's, master's, PhD. Example concept, categories with order means ordinal variables. Different encoding techniques are used depending on the type of variable. Label encoding. Label encoding converts each category into a numeric label. Example, city encoded value, Toronto 0, Ottawa 1, Montreal 2. Example concept, categories means assigned integer labels. Label encoding is simple but may create false relationships between categories. For example, Toronto equals 0, Ottawa equals 1, Montreal equals 2. This might incorrectly suggest that Montreal is greater than Toronto. Therefore, label encoding is usually used for ordinal variables. One-hot encoding. One-hot encoding creates a separate binary column for each category. Example dataset, city, Toronto, Ottawa, Montreal. After one-hot encoding, Toronto, Ottawa, Montreal, 100,010,001. Example concept, category means multiple binary columns. One-hot encoding prevents artificial relationships between categories. Dummy encoding. Dummy encoding is similar to one-hot encoding but removes one column to avoid redundancy. Example concept, one-hot columns means drop one column means avoid multicollinearity. This technique is commonly used in regression models. Frequency encoding. Frequency encoding replaces categories with the frequency of occurrence in the dataset. Example: city frequency, Toronto 50, Ottawa 30, Montreal 20. Example concept: category means frequency value. This technique is useful when there are many categories. Target encoding. Target encoding replaces categories with the average target value for that category. Example concept: category means average target value. Example: city average sales, Toronto 120, Ottawa 95, Montreal 110. This technique is often used in advanced machine learning models. Choosing the right encoding method. The best encoding method depends on the dataset and algorithm. Encoding method best use. Label encoding ordinal variables. One-hot encoding nominal variables. Frequency encoding large categorical features. Target encoding advanced predictive models. Example concept: dataset type means choose appropriate encoding method. Selecting the right encoding method improves model performance. Example Python code. Encoding categorical variables can be done using scikit-learn. Label encoding example from sklearn. Preprocessing import label encoder. One-hot encoding example from sklearn. Preprocessing import one-hot encoder. Example using pandas. pd.get_dummies. Data. City. These tools help automate encoding in machine learning pipelines. Encoding workflow in ML. Encoding categorical variables is part of data preprocessing. Example workflow: raw dataset, down pointing arrow, data cleaning, down pointing arrow, handle missing values, down pointing arrow, encode categorical variables, down pointing arrow, feature scaling, down pointing arrow, train machine learning model. This prepares the dataset for machine learning algorithms. Real-world applications. Encoding categorical variables is used in many AI systems. E-commerce. Encoding product categories for recommendation systems. Finance. Encoding transaction types for fraud detection models. Marketing. Encoding customer segments for prediction models. Healthcare. Encoding patient information for disease prediction models. Customer analytics. Encoding customer behavior categories. Concepts learned from encoding. Understanding categorical encoding helps learners understand. Checkmark how machine learning models process categorical data. Checkmark how different encoding methods work. Checkmark how encoding affects model performance. Checkmark how preprocessing prepares data for ML algorithms. Checkmark how categorical features influence predictions. Encoding categorical variables is an essential skill in machine learning and data science. Simple definition. Encoding categorical variables. The process of converting categorical data into numerical format so that machine learning algorithms can process it. Final summary. Encoding categorical variables is a critical step in machine learning preprocessing. Since machine learning models require numerical inputs, categorical values must be transformed into numeric representations. Techniques such as label encoding, one-hot encoding, frequency encoding, and target encoding allow machine learning models to process categorical features effectively. Choosing the correct encoding technique helps improve model accuracy and ensures that categorical information is properly represented. Understanding categorical encoding is essential for building real-world machine learning systems and data science applications.